Well, welcome back to my Blender series on creating detailed models. We're moving along with our BF109G model. In the last chapter, we created this base mesh for our airplane, and the next step is to create the wings of the airplane. Now, wings are a special attribute, and you just can't kind of slap something on here and call it a wing. The curvature of the wing is critical to how it fits in with the fuselage, and it's going to make or break your model in many ways, because every aircraft has a unique curvature, and it's obviously a unique profile to the wing when looking at it from the top or looking at it from the side. But also importantly is the actual curvature of the wing. Obviously the leading edge is going to be thicker and the trailing edge is going to be thinner, but the core of the wing on every plane is going to be different. There's all kinds of airfoil designs, and some aircraft have even multiple different types of curvatures depending on whether it's at the wing root or the wing tip, and sometimes the wings twist. And all these things are important in making your aircraft look realistic. So going back to chapter 1 where I talked about research, this might be a time to go back and do a little bit more research. So, go to Wikipedia, for example, and maybe find some interesting tidbits here that will help us design our wing. If we scroll down here, see if I can find it quickly. All right, down here, it talks about the airfoil of the BF109 as being a 2R1 profile, and that it used, I'll see it here, it uses Fry's ailerons, which we'll talk about later, but that's also going to be an important attribute of the wing, how the ailerons work. And we also see here that it has a dihedral of 6.53 degrees. Right, so that's important also, because that's the dihedral is you're looking at the front, it's this angle here from the horizontal up. So this angle here we know is 6.53 degrees. Knowing that number is a big deal because our drawings may not be accurate. This angle here may be correct, maybe it's not, but if we can actually know the data, then we can measure that angle and we can place the wing at its proper angle. And that's a big deal. Other things you might want to look at is if you're lucky, your drawing comes with some cross sections. So if we look at our fuselage section drawing, we were fortunate in that we have a couple of, let's get rid of this one. I want that one. So you can see that I have a wing root cross section of the airfoil. You can see that shape. So that's a good start. And we also, from one of our drawings that I've included here, have a couple of other airfoil cross sections, also important. And these even have extra details because the 109 had leading edge slats, and you can see here, this is the slat sitting on top of the airfoil. So that'll be useful later, and then here's the aileron cutout as well. And we'll talk about that in a later chapter, because how these are rigged and how these are hinged makes a big deal in how they move and whether they're accurate or not. But at least for this plane, we're fortunate enough to have 3 airfoils that we can work from. If you don't have airfoils that you can work from, maybe you'll be lucky and you can find the NACA profile number for the wing. 109 has what was called a 2R1. I'm not familiar with that formula. If you have an NACA number, you can go to this website here, and you can actually key in the data for it, and it'll plot a wing for you. If you're lucky, someone else has already done that for you, and you can just download accurate airfoil. So here we have a B29. There's the root, and there's the wing tip. You can see what a huge difference there is between the two. So it's not just a straight line, and the curvature changes over time. So like I said, if you're lucky, maybe you'll get something out of here. If you're lucky, maybe you'll know what the NACA number is, and you can plot your own data. And like we said, we got all kinds of airfoils here. So different ways to create the airfoils, but the takeaway here is don't just kind of wing it. Don't just make up numbers and shapes as you go along. Really try to find that data, because the shape of the airfoil is going to directly, it's going to be easily visible when the airfoil meets with the fuselage. If the airfoil's not right, then it's going to be obvious. It's just not going to blend well. The fairings aren't going to look right. It's going to be obvious that you didn't do your research. All right, so to save time, I created some wing sections here behind this. And all I did was I traced these, and I traced the wing root. You can see that's right there. And this is exactly the same thing I did when I made the fuselage cross sections. I just traced points to trace the shape, making sure that each one of these has the same number of points in roughly the same place, right? Because we're going to loft these. Another important thing to remember is, let me turn off subdivision. So you can see you want some points fairly close to the tip, otherwise this will round off too much. And on the 109, the trailing edge was sharp. So you want these points pretty close to the tip, so you get a nice sharp edge there. And you probably want a few more points around the front to make sure you keep this curve here. If you don't have enough points here, it's going to be kind of blunted. So a few more points here. Spread your points out across the top and bottom to make nice smooth surfaces, and then have a couple of tight points at the back to make sure you have a nice crisp line. All right, so those are our airfoils. Let's take a look at the front. And I'm going to say, well, we'll say it from right about there, because it looks like the wing comes down and then flattens out across the belly a little bit. So if I put my cursor there, And we said a minute ago from our research that the dihedral of the 109's wing was 6.53 degrees. So if I create a plane here, and I'm just going to get rid of those vertices, and I'm going to move this up so that it's there and right about there, right about where the wing root is. I'm going to put my cursor there, and I'm going to move this out here. So now I have a horizontal line. I've got my angle of rotation is here because I'm on my 3D cursor. If I take that and I hit R 6.53 negative, there's my angle of rotation. All right, so I've got 6.53 degrees. Now the key thing here though is you want it from the wing, from the center of the wing line. All right, so if we look at it from the back, the front, we can see that we don't really match front to back because our drawings don't quite match. But if we move this to what's probably the chord of the wing, we can see that the back drawing is probably the better drawing, right? So from the front, what I'm doing is I'm trying to line it up with what I'm thinking is the center line of the wing. We don't have that in our drawing, but often in the NACA drawings, you'll see like a wing, like a line going through that's the kind of the mathematical center of the curve. So I'm trying to kind of eyeball that here, but we'll say that's what that is. And if we look from the back, it looks like our back drawing is pretty good, right? We're going from the center of the wing tip to the center of the curve here. From the front, it looks a little low. But we also said, if you remember from early on in the project, that the rear drawing is probably the better of the two. It seems to be the more accurate. So that makes sense. It's kind of like double checking our work. I'm happy that this line meets up pretty well with the front. All right, so let's take a look at our wings, our wing sections. Notice that the wing sections are spread out. I've gone to the bottom view, and I've taken each one of these wing sections, and I've moved it into position where it fits on the wing. So you can see this one fits front to back. This one actually could move out a bit. Now normally you would put it where the station line is. Sometimes you can, sometimes it's better just to kind of move it back and forth until it fits. So I'm looking to see that it fits front to back here. All right, this is really station 13, I think, is what the drawing said. So if I moved it all the way out to here, it would be too big. So I'm going to put it here where it fits. It's a little bit of a kludge, and I'm going to do the same thing with this. I'm just going to move this to where it fits, right? And you want to do this with subdivision on, because if you turn it off, you can see that the size of your curve changes because it pulls a little bit. And since you're going to be finishing up with a subdivision, you want the subdivisions on while you're placing your segments. And this one I'm going to keep where it is at the base there. All right, and we can adjust the angle later to make sure that we match this. But so for right now, I'm going to make, like I did before, I have these in a collection here. I'm going to make a duplicate of this collection, because I like to have a backup just in case I mess it up, because that happens. And I'm going to grab these things, Control J, to group them together. I'm going to turn off subdivision momentarily, or for a little bit, and we're going to do the loft again. We're going to loft from there to there. There we go. And there. And now if I hit F and just hold it, it'll just loft around. All right, there's the beginning of our wing. You can see that's fitting in there. Now we're going to worry about this joint much later. We're not going to worry about that right now. If I look here from the front, obviously our wing is well short. We didn't unfortunately have a lot of cross-section references in our wing as we went along. So we're going to have to kind of extrapolate out here. And one way you can do that is you hit the G key twice, and then pull it back along the normals, and then hit the C key, C for Charlie. You can see you can extend it and follow the normals right on out. All right, that'll just move that line out for you. And if you look from the top, we're now past the point of the tip. One thing we probably want to do here is I'm going to change out of MatCap. And make it easier for you to see, we'll go with random. All right, so if I go hit GG again, I'm just trying to make this line parallel. And if you remember from the last video, I used the Control Q as a way to, as a shortcut for my space vertex tool. But you could also do loop tools and then space. But I have a shortcut for that. All right, so now I've got my wing tip extended past the tip of my wing. I have my front. Now you might notice that there might be a dip here. So for example, if I didn't have these points exactly lined up, there might be a dip. In this case, what I think I might do is I might actually delete that and see if that works better, because it seems like a pretty consistent transition. It's not like that B29 drawing where the wing was hugely different on the inside and from the outside. This one seems like a pretty straight run between the two. So I think maybe I can get away with just the two chords, and that'll keep the number of polygons down, and it'll ensure that there are no bends in the wing. All right, so from the top, now that I took out that bend, I am going to add something here, kind of as just a placeholder here, just to we'll clean this up later, but I just want to add a little bit more geometry to hold things steady while I do the next step. The next step is going to be cut this out here. Actually, you know what we should do next step? We should make sure that our wing is at the right angle, which it is not. So if I go to tab, go into vertex mode, I'm going to grab all these, just make sure my cursor is at the center of the wing there. Now I can take everything, I'm still in cursor mode. I want to rotate the wing up until the trailing edge is matching my 6.53 degree angle. And it's not going to look right from the front because I think the front drawing is not accurate, but it doesn't look too bad from the back. And if we look from the side, if I put in the different side, we have different side drawings, seems to fit pretty well with that angle there. So I think we're on the right track. Yeah, I think we'll go with that. All right, so we got a good angle on the wing. We got the wing past the edge there. Next thing to do is cut this tip here. You could, if you wanted to, use a knife tool and just cut these manually. What I think I'm going to do here, though, is a little different. I'm going to use a curve to cut that wing tip because that'll give me a nice smooth curve. So let's rotate that and go into edit mode and just kind of get these roughly in position first, kind of tangent to the wing, and then I can push and pull the edge points to get it. You can even add a subdivision if it's a little chunky, if you want to see what it looks like a little smoother. So move that to be kind of tangent. You still want it outside the edge there, otherwise the cut will not cut all the way through all the surfaces. And sometimes it's a matter of going from one to the next, playing with them till you get something that's right. And I'd rather do it with just two, because the more points you put on your curve, the more likely you are to have a kink. And this is a pretty smooth curve here. Almost. Yeah, I'm sorry I'm boring you with this. All right, so there's the curve. We'll go with that. And this can always be adjusted a little bit later, just like we did with the like the rudder in the last lesson. We kind of pushed and pulled a little bit more just to refine the tip once we were done. But this gets us pretty close to what we want. So make sure you apply your rotation and scale. Go into edit mode, and then left mouse control click on the curve, and that'll select the curve as well. And then if you hit F3, bring up your tools, and if you type knife, you can select knife project. And make sure you hit cut through, right? Because that'll project the cut all the way through both sides of the wing. So now if we look at our wing, we've got both sides cut through. And we can just select these edge vertices, and we can get rid of those. And there's our wingtip. All right, so we're done with that. I can just move that to my junk pile, get that out of the way. All right, so the next thing is we need to close up this tip here, clean it up a bit. We have some extra points because the curve had some vertices that didn't quite line up with our mesh, so it's going to put some extra verts in. We're just going to clean these up because we do not need them. Because this is the base mesh for later on in the model. So we can have some wiggle room in what we do here. I might leave that one for now. And now I just want to fill this edge here. And hopefully now that I've gotten rid of all the extra verts, it'll just fill. I'm just hitting F here. Fill all the way along. And you can see we've got a little bit of bumpiness there. Right, you've got some jaggy stuff going on. Hitting GG just to kind of pull the edges back to make things a little smoother. Now if we look at some of our reference material, I've got a PureRef page here with some wingtips on it so we can see what we're trying to shoot for here. So this one's a good one. It shows that the front edge of the wing is quite rounded, but then becomes sharp, particularly in the latter half. It really is blended with the trailing edge right up to, I don't know, third of the way, quarter of the way, halfway across the wing, something like that. Another picture of the wing. So rounded front, blunt, and then transitioning to sharp. All right, so that's what we're shooting for here. And if we go into here and add one more edge loop, right, because we had triangles on the end, so that worked out pretty well. And I just like to give a little bit of an angle to those, so it makes it a little bit more of a quad. And let's see what happens when we put on subdivisions here. What does it look like? Not too bad. And we got if we look at it from this angle, it's a little thin maybe in the front. We can blunt that up, but it does transition nicely toward the back. So how do we fix this? Well, one thing we can do is we can try just to relax some of these points and see if that helps. So if we go into vertex mode and smooth the vertices. See how that works. And what I think I might also do is I might just merge these. Just going to make a blend there. Let's see what that looks under subdivisions. That definitely looks better. All right, we don't have that sharp, we don't have an edge like, we used to have more of an edge like that. We've got more of a transition there. And I'm going to do the same thing back here. See if we can do something similar. What do I want to do here? Maybe just get rid of this entirely, because it's just too many points, and see what happens. Now, does that look better? Yeah, that definitely looks better. All right, so we're getting there. We got kind of that elliptical shape. And obviously, we got a little bit of shortness on the front and back, and at the wing root, it's a little bit off. So what we're going to do is we're going to use our friend the lattice to fix that. So put the cursor kind of right there. I'm going to add a lattice, scale it up. Make sure we're surrounding the wing. Good. And we'll start off with no subdivision, so I want to kind of make some gross adjustments here. So add a lattice, choose our lattice, go into edit mode, and I'm just going to move the trailing edge back. And because we're using a lattice, it's affecting the whole thing here, which is nice. So again, just general shape here. You're going to start with big shapes first, and then work your way into details later. Right? It's too easy to get bogged down into details too soon. You definitely don't want to do that. You want to just do big shapes. All right, so I'm actually going to apply that lattice since it generally has what I want. I'll get rid of that one. I'm going to create another one. All right, and this one, we're really just going to concentrate on the wing tip here. So that means I need to add some resolution to this. It's maybe too much. I'll try that. And yeah, I'll try that. I'm going to move it here. Maybe I'll add another one. What I'm trying to do is I'm trying to set it up so that I have some generalized control, just like in these two quadrants here. All right, so add a lattice again. Choose our lattice. And now I should be able to kind of work just on the tip of the wing. Reshape that. That one's not too bad. All right, I can live with that. Maybe a little bit more. Yeah, sometimes you're dealing with, like, do I draw it on the inside or the outside of that line? We're talking about tiny amounts here. So after moving stuff around with the lattice, it's possible you could have deformed it in one of the vertical axis maybe. So take a quick look around. We can always smooth things out. But the goal here is you want to do small movements. You can see we didn't really deflect too much there. Because if you do too much, you end up distorting stuff. All right, so that is our base mesh so far. I can apply that lattice and get rid of this. Let's go back to material mode and take a look at the mat cap. And one thing you might want to do is just double check. Sometimes the normals get flipped. So let's take a look at face orientation up. There we go. So select all, hit Shift N, and now our normals are face up. I can turn that off. We can turn it off. Now we get a better look at that wing. And what I'm doing here is I'm just kind of rolling it and looking at the gloss from that mat cap. See that shiny bit. And if we get a nice straight line, that means we got a nice smooth surface without any dimples. And I got a little bit of maybe dimpling in here. I'll put the cursor there. Hit a 0. So yeah, just in case you didn't see what I did there, I saw like a little bit of a dent here. So what I did is I selected 2 points, hit cursor to selected, and it's going to put the cursor in between them. It doesn't look like because the subdivision's on, but it really is there. And then I select that point, which is the point in between, and I hit S0, and it's going to move it to the cursor, which smooths that out. We've got something better going on there. All right, so that is our wing so far. Just looking to see if we have any more weirdness going on. Maybe I could do another one here. Maybe one here. Just smoothing things out. So, like I said in the first video, it's important that you don't have any more polygons than you absolutely need to. With wings in particular, you have nice flowing smooth lines. And the fewer edges you have, the better this subdivision surface is, because it has broader areas to work over. And have as much dimpling. So I just see a couple dents here that really need to come out. Now, this does affect the shape of the model a little bit, so be careful you don't do it too much, and you got to be cognizant of the area you're doing it in. That's better. So if you were doing it along the fuselage, you could do that averaging trick that I was just doing, going this way along the fuselage, and it would probably work pretty well. But if you were doing it across a curve like this, it would not be appropriate here, because it would just bend this in too much. You can see that it really dents it in. So if you are going to use that averaging trick, do it with the long flow of the object and not around sharp curves. All right, so that is our wing so far. Let's put another wing on the other side just for grins. All right, starting to look like an airplane. Now, another part of this wing is obviously where it meets up with the fuselage here. And I'm going to guess that my orientation is not right and my mirroring is not right, because that wing is wonky. That's better. All right, so in addition to the shape of the wing, how it mates with the fuselage is also important. So here in PureRef, I have some more pictures of the underside of the 109. And we can see, here's a good picture, a nice clean one, that the fuselage blends in with the underside of the wing, all the way up to the trailing edge, certainly, and then up at the front, there's a little bit of a fillet where the leading edge of the wing blends, and you can see it here, that little bit. But other than that, it's a smooth transition straight across. All right, so how do we do that? We're going to create a shrink wrap piece that's going to help blend these two pieces together. So I'm going to turn off my modifiers here for a bit, and I want to pick points that are fairly far apart to represent the wing curvature. So I'm going to pick those, one in the middle, and one there, maybe. Shift D to duplicate, P to separate. And if I hide my selection, you can see I've got these guys. I'm going to make faces out of this. So that's part of our template. I go back into object mode, and now I'm going to take 4 points from the fuselage also. And this is going to represent the curvature of the fuselage. So maybe there, and then down the center line as well. So we've got 6 points in from here and 6 points from there. Duplicate. I'm going to turn off these modifiers. Hit P, separate my selection, hide this, hide that, and we'll go in here and we'll face these up. All right, so now we have these two pieces, this representing the fuselage and this representing the wing. Now if we join them together, and I don't need a Boolean on that, and now I can join these together. I'm just going to, at center, so just kind of get the average of the points, and that is the basis of our shrink wrap. I'm going to put the cursor there, set origin to 3D cursor, mirror it. Oh, looks good. And then hit a subdivision on it. Let's see what happens. So I'm going to get out of matcap mode, go back to random. Maybe a little bit easier to see, maybe not. So that's our shrink wrap piece. I want to take some of these pieces, like here through here, and then across the center. I don't want these because they're outside of our shrink wrap. And I'm going to create a vertex group called belly, and assign them at full power. All right. And then if I create a shrink wrap modifier using the belly vertex group and assign it to my template here, you can see that it starts to adjust the blending of these two. Right, turn that on, turn it off, it starts to smooth it out. So we're going to do the same thing with the wing. We're going to take these points here along the center and add them to a belly group at 100%. And we're going to add a shrink wrap to this as well for that group. And we're going to assign it to our template. Let's hide our template for a minute. Turn all this stuff back on. Turn all this stuff back on, see how we're doing. All right, so you can see it's already starting to blend better. We don't have that sharp edge there anymore. We do have obviously some issues here, so let's take a look. Maybe we can add this one to the shrink. Take that down a little bit. Maybe that one. Yeah, that made it worse, so maybe not. So all those are. Let's take a look at the wing. Maybe the wing's a problem. What I might do is I might add another edge loop here, and when you add an edge loop next to a set of vertices that have weights on them, it interpolates the weights between the ones here and the zeros there, so they're already going to be weighted. So like if I select, you can see that those new ones are also inside the group. We're starting to blend. It's certainly better than it was before. I'm obviously not happy with what's going on here, so it might be that we need to adjust our template a little bit. And if I move this up and down, you can see how that affects the blending. Yeah, some of the problem might be we have too much of the wing as in this group, so if I take maybe that out, see what happens. Yeah, that definitely looks a little better. Still got a bump there. Maybe take these out. Oh. Starts to blend. Yeah, here's a good time to look at our reference images. See if that's too much of a transition. Bring this over. It's a pretty sharp transition, isn't it? A little fillet and a sharp transition. Now, some of this can be fixed later on when we're putting plates on the aircraft, so it may not be super critical right now, but let's take a look at our profiles. It definitely causes a dip there. Not happy with that. And maybe the fuselage is just too tall there. So I take this, select the top one, active element, and I scale it up in the Z. Bring it a little bit closer to our drawing. You know, that's definitely better. You know, some of this is a little fiddly. I'm very tempted to pause the video for a bit and fix this so you guys don't have to watch this. So maybe I'll do that. All right, I'll be back in a minute. All right, I'm back. I smoothed it out better. All I really did was I played with the weights of these various points. Some of them I assigned ones, some of them assigned 0.5. When I got up here toward the leading edge of the wing, I got down to like a 0.15 influence on the shrink wrap, and tends to blend pretty well. If we go back to our mat cap and go back to materials, now ignoring this overlapping bit here, obviously that looks kind of ugly, but the idea here is that when we look at the front of the aircraft, the wings flow right into the fuselage. Right, nice smooth transition there on both sides, which is, if we look at our reference material, that's what we've got. We got a smooth transition from the wings across the fuselage, right, with no stepping except at the leading edge of the wing. All right, so I think that is good enough for now. And again, because of the method we're using, this is all non-destructive. We can modify these things gently later on. All right, well, I think we're running long on this video, so I'll probably end this one here. And then in the next video, I'll talk about the base mesh for the fuselage, the canopy, and if there's time, I'll talk about the base mesh for the horizontal stabilizers. They shouldn't take too long. And I'll put the link to the next tutorial up here, and then the playlist link up there as usual. All right, I'll see you in the next video.